Good morning, Panthers, and welcome to day 4, Thursday. I understand you have the day off tomorrow because it is Good Friday, so this will be the last math for the week. I found another joke that you're probably going to think is horrible. I kind of thought it was funny. It says, what do you call more than one L? And the answer, a parallel. Get it? Pair, two, yeah. I used that joke today because I know one of the problems on your assessment has to do with parallels. So I thought that would be a kind of a funny way to start. All right, I'm not going to give you the answers to anything today because it is an assessment. I want you to look back at the videos if you're not sure how to do it. Use your T-chart when you're doing your problems. I'm going to look at number 4 and number 5 because I believe 6 and 7 you can definitely do on your own. But 4 and 5, they might be a little tougher. So let's take a look with 4. And it says, Sophie runs 1 mile in 6 minutes. If she begins running at 7:20 a.m. and maintains the same pace for 4 miles, what time will she finish her run? So you know the starting time. You know the duration time, but it's a little hidden. So we're going to pull that duration time out of the problem. So let's start with our T-chart. I'm going to go ahead and just write it right on here. I'm going to write time and then hours and minutes. So let's take a look. When did she start? From the word problem, you should be able to figure out that she started at 7:20 a.m. 1 mile she can run in 6 minutes. So how long would it take her to run 1 mile? We're going to go ahead and add 6 minutes, and that would be 1 mile, right? And I'm going to underline that. I'm going to go like that, and I know that's 1. All right, so my hour's not going to change. So 7:20 plus 6 is 26 minutes. Okay, that's 1 mile. She has to run how many miles? 4. So here would be 2 miles, 3 miles, and 4 miles. Asking you, and you can answer me even though I can't hear you, how long does it take her to run 1 mile? What? Oh, did I hear 6 minutes? Very good. So on this side, you are always going to add 6 minutes. And you will get another answer here. All right? 1 mile, 6 minutes, 2 miles, 3 miles, 4 miles. When you get to this answer right here, you're going to have your ending time. When you add 6 minutes to this, you'll get here. When you add 6 minutes to that, you'll get here. When you add 6 minutes, you will get right here. And this would be your answer. Okay? Can you already tell that it's definitely not going to be F? Because we already passed that time up. So there's 1 you can get rid of. All right, very good. All right, let's take a look at number 5. This one, I haven't noticed that you've done one like this before. I'm also going to bring in my nifty-difty paper over here to try to help you out. It says, Jeffrey took an afternoon nap for 2 hours and 15 minutes. Nice nap. The clock face below shows the time he woke up. In other words, the time his nap was over. What time did he begin his nap? So now we know the ending time. We know the duration, how long he slept. We don't know when he started to go for his nap. So this is going to be what I call a work backwards problem. We're still going to make the T-chart, and we still have to figure out exactly what time it is on this clock. So I'm going to look here. I know that the hour hand passed 3, but it did not get to the 4. So I know that it is still the hour of 3. And I'm going to count my minutes by 5, 10, 15, 20, 25, 30, 35, 40. So it is 3:40. That is when he woke up. His nap lasted for 2 hours and 15 minutes. If we add those 2 hours, that's not when he woke up. We need to go backwards in time and figure out when he started his nap. So I'm going to do the same T-chart. I'm going to go ahead and put it this way. Hopefully you can see that. I'm going to put the time, and I'm going to put the hours and the minutes. The duration, I'm going to put 2 hours, 15 minutes. Understand, that's how long his nap was. The only time I know for sure is when he woke up. So I'm going to put 3:40 right here. We are going to do the same process, except we are going to work backwards because his nap is over at 3:40. We need to know when it started. So I'm going to start with my hours, and I'm going to put minus 2 hours, minus, because I'm going backwards in time. I want to know when he went to sleep. So my minutes would definitely stay the same. I'm not messing with them. My hours, 3 hours minus 2 hours is, let me think, 3, 2, 1. Oh, look at this answer right here. I'm already there. Can I pick that answer? I hope you're shouting no at me because I didn't talk about the minutes. So 15 minutes. I'm going to go ahead and go backwards 5 minutes at a time. So minus 5 minutes. I'm going backwards. I'm not adding those. I am subtracting those. So I know that I would leave this alone. The hour would stay the same. Now, 40 minus 5. Going backwards, that would be 35. Okay, but I need 15 minutes. Okay, so I do another 5 minutes. Now this is where I'm going to let you on your own. When you subtract the 5 minutes from here, you would get an answer. 5 minutes, 10 minutes. Oh, I need another 5 minutes. So whatever you get when you subtract here, you want to subtract another 5 minutes. And right there is your answer. I don't think that's too hard for you. I think you can figure that out and you would be able to find one of those answers. Keep in mind, we worked backwards this time. We are subtracting time so that we know when he first fell asleep. And this was a little different. I didn't see a work backward problem on any of the other ones. So I can assure you number 6 and number 7 are regular problems. You should be able to figure those out using your T-chart and adding time. All right, what I'd like to do now is move to your last one. And this is why I gave you that horrible joke about parallel lines, because we're going to be talking about parallel lines. Perhaps. Tiffany sorted polygons into group. Remember, a polygon is any closed figures with straight sides. So these are all polygons, even though they're also something else. The polygons shown belong to the same group. Which description best represents this group? So I see the word quadrilateral. What is a quadrilateral? What is a quadrilateral? Again, I hope you're yelling at me. A quadrilateral has 4 sides. I see quadrilateral, I see quadrilateral, I see quadrilateral. That means that they're talking about something with 4 sides. So right away I can look at this, see if there's 4 sides, and if it has more, you can get rid of it. All right, there's some other words that they're going to be talking about. Perpendicular lines, acute angles, Uh-oh. Parallel sides and equal angles. So they're either talking about lines or angles. What kind of an angle? Acute. You have to decide what kind of an angle is acute. Is it the right angle? Is it bigger than a right? Is it smaller than a right? You should remember what acute means. Equal angles should be quite easy. You know what the word equal means. Equal. Now let's look at the type of lines. Perpendicular lines. Those are the ones that are going to make that nice straight angle. Perpendicular. So it could look like that, it could look like that, it could look like that, but it makes that right angle. That's just a little gift from me. Perpendicular. Parallel lines. A para. Remember, in that word is the clue. Parallel lines. This is perpendicular, and this is parallel. And that's all I'm going to say about those. Now you decide. Do they all have perpendicular lines? Do they have no acute angles at all? Do they have two pairs of these parallel sides? Or do they have all four equal angles? So I left you a little cheat sheet, and the rest you can do on your own. So this is the end of your lesson for Thursday. I hope everybody has a blessed Easter. Please stay safe. Stay with your family in your house. And I'm really hoping to see you in May. Thank you.